Welcome to Science Tree channel, and here we go with the topic, which is physical and chemical properties of alkenes. Now you're quite familiar with what is alkene and how we can prepare alkenes. For more knowledge, you can watch my previous video. So what are the physical properties of alkenes? The word physical properties means all those properties which can be judged by 5 senses, means by watching, by smelling, by tasting, or by hearing or touching. So the physical properties of alkenes means that all those properties which can be judged or which can be understood by appearance. Alkenes at least required 2 carbon atoms because we need a double bond between 2 adjacent carbon atoms for alkenes. So here we have ethene. Eth is representing 2 carbon atoms and ene is representing the double bond which is present between 2 carbon atoms. The first member of the alkene is ethene. It is colorless gas with pleasant odor. So now here we can understand it by means of senses. Pleasant odor and colorless gas. So it's a physical property. Alkenes are non-polar. Therefore, these are insoluble in water but soluble in organic solvents. Now they are non-polar because the bond is formed between carbon and hydrogen and there is less electronegativity difference present between them, and they have a covalent bond between them, the bond which is formed by the sharing of electron. So how it could be a polar one? Because for polarity we needed complete transfer of electron to get a positive or negative charge. Complete transfer means to give positive charge, loss of electron, and the gain of electron will give negative charge. So now here there is no complete transfer of electron is taking place. There is only a sharing of electron between carbon atoms and hydrogen. So alkenes are non-polar. And non-polar dissolve in non-polar substances, while the polar dissolve in polar substances. As there is a universal rule, like dissolves like. The first member of the series, ethene, is slightly less dense than air. Alkenes are flammable. It means they are combustible. They can burn. On complete combustion, these form carbon dioxide and water with release of energy. But lower alkenes are more combustible than as compared to the higher alkenes. Their melting and boiling point gradually increases with the increase of molecular size of the compounds. Like if I talk about carbon number 10, carbon number 12 and so on, like from 15, 18, carbon number 18 means that a substance having 18 carbon atoms in it. So definitely with 18 carbon atoms, it has higher molecular size and weight than as compared to carbon number 2, which have 2 carbon atoms. So that's why with the increasing number of carbon atoms, their melting and boiling point increases. Now in case of chemical reactions, the most important question which used to come in exam is that why alkenes are most reactive. So alkenes are reactive compounds because the electrons of the double bond are easily available for reaction. They have tendency to react readily to become saturated compounds. Now here, this is ethene, and this double bond is representing sigma and pi bond. The lower one is sigma bond, and in the upper one we have pi bond. Sigma bond is stronger than as compared to pi bond. But why? Yes, because in case of sigma bond, S subshells are overlapping. And we know that S subshells are circular in shape. So head-on-head overlap takes place. Or in simple words, we can say that more overlapping is taking place. And if I talk about pi bond, it is formed between P subshells. And P subshells are dumbbell shaped. The overlapping is taking place between tails. So that's why they are little bit overlapping than as compared to S overlaps. So weaker overlapping is taking place. That's why pi bond is weaker and easily breakable. So when we break it, the free electrons will gonna form a bond with other atoms and making this ethene more saturated, making this hydrocarbon more saturated. Alkenes gives addition reactions. And so as we know that they are unsaturated compounds. So this unsaturation means that they have space, they have accommodation. And where is that accommodation? That accommodation is double bonding. Okay? So the double bonding means that these are the reactions in which products are formed by the addition of some reagents like hydrogen, chlorine, or etc. to an unsaturated organic compound. In this process, one of the bonds of a double bond gets broken, and we have discussed that that will be the pi bond, and two new single bonds are formed. So they undergo addition reactions. Hydrogenation of alkenes. In this reaction, what we will going to do with alkenes? Yes, we will add hydrogen. Hydrogenation means addition of molecular hydrogen to an unsaturated hydrocarbon in the presence of catalyst, nickel or platinum, to form saturated compound. Ethene is reacting with hydrogen. Now, what gonna be happened? Ethene having double bond in it. One of the bond of ethene, which is pi bond, will gonna break, and this carbon has its free electron available. Similarly, the carbon number 2 will also have its free electron because this second bond, pi bond, is broken. These free electrons will form a bond with hydrogen. These two hydrogen atoms are linked together by means of a single bond, and this will gonna be break. So definitely hydrogens have their own free electrons. So one of the hydrogen will form a bond with one of the carbon, and the second hydrogen atom will form a bond with second carbon atom in the presence of nickel and platinum having temperature 250 to 300 Celsius, and we will get alkene. From alkene we get alkane. The unsaturated compound is changing into saturated compound. On industrial scale, This reaction is used to convert vegetable oil into margarine, vanaspati ghee, a very common reaction which is known as Spatier-Sandrin's reaction. Halogenation of alkenes. It means that alkenes are saying welcome to halogen. Halogen, group number 7A. Fluorine, chlorine, bromine, iodine. So halogenation means addition of halogens. Okay? This is again ethene, and we are adding bromine in it. So which of the bond will gonna break? Yes, you are genius. Pi bond, the upper bond, and carbon have their free electrons available. So the bond between the bromine atom will also break. So one of the bromine will form a bond with one of the carbon, and the second bromine will form a bond with second carbon atom. And here we have done halogenation of alkenes. Now the next reaction is hydrohalogenation of alkenes. The word indicates hydro means hydrogen. Halogen, group number 7A. So here we have to add hydrogen and halogen to alkenes. Hydrogen halides are colorless gases at room temperature, producing steamy fumes in moist air. Again we are taking ethene here. This ethene will react with hydrogen halide and will give us alkyl halide. For example, we are taking here hydrogen bromide. So one of the bond of ethene will gonna break, and one of the carbon atom will form a bond with hydrogen, giving us alkyl. Okay, when we have 3 hydrogen atoms with carbon, we will gonna name it as alkyl. And if it is 4, it means we are talking about alkenes. When carbon is satisfying its valencies with 4 hydrogen atoms, we are talking about methane. But here there is 3 hydrogen atoms, and one of the bond of the carbon is with some other substance. Okay, so this is alkyl, and next carbon, CH2, carbon number 2, is forming a bond with bromine. So here this is alkyl bromide, or we can say that 2 carbon atoms means that this is ethyl. Okay, ethyl bromide. A very important question which you have to memorize: the order of reactivity of hydrogen halides is hydrogen iodide is more reactive than hydrogen bromide, and it is more reactive than hydrochloric acid. But have you ever think about it that why? Let me tell you. Hydrogen iodide has the lowest bond dissociation energy due to longer bond length. That's why it is more reactive. Okay? Now the most important reaction is oxidation of alkenes with potassium permanganate. The word oxidation means gain of oxygen. There are some other definitions as well, which is loss of hydrogen and loss of electron. So it all represents oxidation. Potassium permanganate is a very strong oxidizing agent. So oxidizing agent means that it will reduce itself to oxidize others. And in this case, potassium permanganate is reducing to oxidize alkenes. Okay? Now, potassium permanganate, manganese has a valency positive 7, while in product MnO2. Okay, and here manganese has valency positive 4. So now manganese reduces from positive 7 to positive 4 as it gains electron. So that's why here reduction occurs. It proves as potassium permanganate undergoes reduction, it will oxidize ethene. For oxidation, the pi bond will break down and this ethene have free electrons available on carbon by breaking down the pi bond. And these breaking or these free electrons will form a bond with hydroxyl groups, 2 hydroxyl groups, which it takes from water. So in this way, a reaction occurs with dilute acidified potassium permanganate solution which reacts with alkene, and the color of reaction will change. Potassium permanganate is pink in color, but after reaction it becomes colorless, which shows that potassium permanganate reduces to oxidize it. Now these 2 hydroxyl groups are present on adjacent carbon atoms, so they will be named as glycol or 1,2-ethene diol. Now in this reaction, how we can balance it? We have to count the number of atoms in the reactants as well as in the products. Now in the reaction, we are taking how many number of carbon atoms? There are 6. Okay, 3 carbon atoms are carbon number 1 as we are taking 3 molecules of ethene, and this 3 is also with this carbon atom. So 3 plus 3, 6. And in the product, we have 6 carbon atoms. So now carbon is balanced. Hydrogens. Here we have how many number of hydrogens in the reactants? 3 2s are 6. So again, this 3 is with the second hydrogen atom as well, which is with carbon. So this 3 2s are 6. 6 plus 6, 12. Now we have hydrogen in water as well. So 4 2s are 8. Now 8 plus 12, 20. So we have 20 hydrogen atoms in the reactants. While in the products, we have 3 2s are 6. Again, this 3 is also with second carbon atom. So 3 2s are again 6. So 6 plus 6, 12. Now we have hydrogen atoms in alcohols as well. And as it is attached with carbon, so the number 3 is also again used with this hydrogen as well. So in hydroxyl group, we have 3 hydrogen atoms in carbon number 1 and 3 carbon atoms in carbon number 2. Or we can say that for 3 ethene molecules, we need 3 hydroxyl groups. Okay, so for 1 carbon, we have 3 hydroxyl groups. To satisfy other carbon atom, we again need 3 hydroxyl groups. So 3 hydroxyl groups plus 3 hydroxyl groups means we have 6 hydroxyl groups over here, and 6 hydroxyl groups have 6 hydrogen atoms. So the above one were 12, and 12 plus 6, 12, 13, 14, 15, 16, 17 and 18. And the rest of the 2 hydrogen atoms are with potassium hydroxide. Here, this hydrogen is 2. So we have 18 plus 2, 20 hydrogen atoms. Now potassium, we have 2 potassiums over here and 2 potassium atoms over here as well. For manganese, we have 2 manganese atoms over here, and again in the product we have 2 manganese atoms. Now for oxygen. So oxygen have 2 4s are 8 and 4 oxygen atoms with water. So 8 plus 4, 8, 9, 10, 11 and 12. Okay. Then in the product, we have 6 oxygen atoms with ethane 1,2 diol. Okay. And rest of the oxygen atoms will come from manganese. Here we have 2 2s are 4. So 4 plus 6, 10. And these 2 oxygen atoms means 12. So we have 12 oxygen atoms in the product as well. In this way, we balance the number of atoms in the reactants as well as in the products. Thank you so much. For more videos, keep watching. Have a great day.